The video shows the UniAS wheel sensor with a side cable connection. Other versions of the wheel sensor are installed in the same way. Let's start the installation of the wheel sensor holder. First, attach the profile to the holder base. Use M10 screws for this purpose. Pay attention to their dimensions. You need longer screws at this stage. The selection of installation openings in the base depends on the profile of the rail. Slightly tighten the screws by hand as presented on the screen. This is how the correctly installed profile and holder base should look like. Install the wheel sensor to the other profile at the next step. Use M10 screws with profiled fastening, which prevents screw rotation during installation. Place the screws from the side of the wheel sensor and then install washers and self-locking nuts. Pay particular attention to the appropriate sequence of the washers. Remember to keep a small degree of initial tightening. Screws can be tightened by hand or with a 17 socket wrench. The next step is to screw the sensor to the holder base. Place the profile with the sensor on the base in the middle of the adjustment openings. Next, slightly tighten two M10 mounting screws. The holder is ready for installation in the subgrade. Let's move to the installation of the sensor. Place the previously assembled holder on the rail foot. Tighten the first nut by hand. This will be easier if you temporarily remove the second nut. It should be noted that the sensor does not touch the rail head. Tighten the first nut. Use a torque wrench with a 30 socket, retaining the tightening torque of 80 Newton meters. Next, tighten the self-locking nut, maintaining the preset torque of the wrench. To tighten the sensor mounting nut, use a 17 nut with torque of 15 Newton meters. The FP52 fitting part facilitates the verification of the wheel sensor placement. If the plastic part of the fitting does not adhere to the rail or the sensor is not in the horizontal position, start the adjustment. Loosen screws and set the element according to the fitting part in the horizontal axis in relation to the rail head. Tighten the screws. Next, carry out the adjustment in the horizontal axis. Set the sensor so that the fitting part adheres both to the rail head and to the sensor. After adjusting the position, tighten the adjustment screws with a torque wrench with a 17 socket, with the tightening torque set to 35 Newton meters. After installing the sensor on the rail, or in case of any change in its position, it is necessary to tune in the sensor. This can be done with MT51 testing module. After connecting the sensor and switching the testing module on, the range of value of the sensor current is shown. The sensitivity switch should be set in the Tune mode. Call up tuning by pressing the Auto Tune button. After completing the tuning, green LEDs should be lit. Connecting the ammeter to the MT51 testing module via the multimeter instead of the jumper enables to verify the present value of the current of the wheel sensor. The tuned-in UniAS sensor should have the quiescent current without the wheel over the sensor close to 20 milliamperes. The allowed range of values is from 19.7 to 20.3 milliamperes. Moving the fitting part along the rail enables to verify the operation of the sensor. Red LEDs indicate a drop current caused by the presence of the simulator over the wheel sensor. After mounting the sensor on the rail, adjust its position in relation to the rail head. To do this, you can use a tape placed between rails. The distance should be between 40 millimeters plus or minus 1. The adjustment is done using the screws at the bottom of the holder. Next, check the distance from the head. It should be 56 millimeters plus or minus 1. After the adjustment of the sensor position, tighten the adjustment screws with the torque wrench, with the torque value set at 35 Newton meters. After drawing the sensor cable into the track side box, verify the value of quiescent currents of the sensor. The sensor cable has 4 wires. Connecting the ammeter into line number 1 enables to measure the current of the HD1 coil. The value of the quiescent current should be within the range of 19.7 to 20.3 milliamperes. The HD1 coil of the sensor is tuned by reversing the polarity of the supply voltage by replacing cables 1 and 2. The polarity reversal should take about 10 seconds. After tuning the HD1 coil, restore the correct polarity of the supply voltage and re-measure the value of the quiescent current. The HD2 coil is tuned in the same way. Remember that this time the polarity reversal should involve cables 3 and 4.